So on the homework on 9.7, it says in 2012, the population of a city was 6.87 million. That's important. And it's also important that it was in 2012 is when this is happening. It says the exponential growth rate was 1.56% per year. There is a formula that you can use that says the population is equal to the population sub zero, which means the initial population that you had before anything happened, times E. And remember, E is a number, just like pi. It's like 2.8 something. And we use it for compounding growth. Okay, K is going to be our exponential growth rate. And T is going to be the number of years that go by. So this is just a general formula. So if the first question is asking me, well, what is the exponential growth function? Then I'm going to say, well, P sub zero. P sub zero would be whatever I had to begin with, and I've got 6.87 million. They're also telling me that I can leave it like that. I don't have to write all the zeros after it because it says it's okay to leave your population in millions. So I'm just going to put 6.87 right here. Then the next thing is an E. So I'm just writing that down. K. K is the growth rate. And you have to make sure you divide that by 100. They don't want the percent. They want the decimal. So 1.56% divided by 100 is 0.0156. We've got to move that decimal over twice. So 0.0156 T. That's what goes right here. T is the number of years that have gone by. So 6.87 E to the 0.0156 T. Okay, it says the population of the city in 2018 is, okay, I got a couple of ways to find this out. First thing I know is, well, T represents the number of years since 2012. So if it's 2018, I'm going to have to figure out, well, how many years have gone by from 2018 to 2012, right? So 6 years. Okay, and then you're right, I'm going to plug this in. Is that so? I'm plugging in 6 for T. Okay. So you could actually type that in your calculator and then put a 6 right here because we're looking at 6 years. But I know what's coming on some of the other problems, and I know it would be valuable for me to go to my graphing calculator and go, okay, let's just go ahead and put this in y equals. And type in our function, which was 6.57 or 6.87, sorry, 6.87. Then it said E, so second ln raised to the 0.0156. And I've got to use X. I can't use T because we don't have T. And now I can go, oh, I want to know what happens after 6 years. I'm going to go look at my table. Okay, so I go to my table and I go, oh, 6 years, 7.5441, right? There's the answer. So 7.5441, I would also get that if I just plugged it in the equation. So I could go back and write down my answer because they said they want me to round to 1 decimal place as needed. So the right answer would be 7.5. Okay. Then it says, what is the population of the city will be when will it be 11 million? Okay. So that is the answer to the population. So they're saying, okay, let 11 million be equal to 6.87 E to the 0.0156 T. They're asking you what T would be. Okay, so I can't use my calculator to give me the answer, but I can use my calculator to see if I'm on the right path. So we're wanting to know when this Y1 column, when the answer is 11. So I'm gonna scroll until I get close to it. Okay, so it looks like it's happening between the 30 and the 31st year. 10.97 and 11, so we're looking for 11. So that's gonna tell me at least if I'm kind of on the right track with my answer, but I am gonna have to use some algebra to solve this. So what can we do here? We just got through working problems like this. So we know that we are going to have to get this E by itself because we got to get this T to come down. So this is another reason why I wanted to show it. So we're going to need to divide both sides by 6.87. So we would get 11 divided by 6.87. And when you do this, you're going to get a decimal, and you don't want to, go ahead and write down everything on the screen because this problem is being rounded to one decimal place. And if you cheat too much and round too much up front, you're going to get the answer wrong. These 6.87s canceled out. Everybody okay with that? Okay, this looks exactly like what we just got through doing. I need to get this T to come down. So what do I need to do? You got to take the natural log of both sides to get that to happen. Because now there's this property that says that if you take the natural log, you can move the exponent in the front. So I like to try to not do too much at once because of the rounding situation in the calculator. So I'm going to go ahead. If you don't need to write down this step, that's fine. This is mainly for you. So I'm going to move the 0.0156 T in the front, natural log of E. I want my answer to give me T. So that means I need to divide by everything that's not T. I need to divide by 0.0156 and natural log of E. Remember that the natural log of E is just 1, so you really don't need it. But just trying to make sure I'm showing you all the steps. So this is going to cancel. This is going to cancel. And whatever this is should be my answer. So this times the natural log of E, which is just 1. So natural log of 0.16, all that stuff, divided by 0.0156. I don't really need to divide by the natural log of E. It's just 1. So if you want to do it, it's not going to mess you up, but just don't need to. That's 30.175, and it just keeps going. We said it was supposed to be between 30 and 31, right, on our calculator? We're supposed to round this to one decimal place, so 30.2. Everybody okay with that? Okay. The doubling time. So what do you think that means, doubling? The time it takes for the population to double, right? So I'm starting out with 6.87 million. So if I double, this is C, this right here, I'm starting D. If I double 6.87 million, I'm at 13.74 million. So all I'm doing is figuring out, well, they want to know how much time it's going to take my population to double to get to 13.74 million. Hey, I can go back to my calculator and I can go, well, let's get some kind of idea. So I'm trying to find 13.74, 13.4, 13.6. So it's between 44 and 45 would be 13.74. So I kind of know that that's what my answer needs to be, somewhere in there. So the problem is, when is 13.74 equal to our original equation, 6.87e to the 0.0156t? This problem's work the exact same way. I need to get E by itself. So I need to get rid of 6.87. So I would divide by 6.87 on both sides of my equal sign. I got the 13.74 because I multiplied that by 2, because they asked me what the doubling, how long it would take for it to double. So this is just 2 is equal to e to the 0.0156 t. Okay. We know that if we're going to get that t to move down, we're going to have to take the natural log of both sides of the equal sign. So I've got the natural log of 2 is equal to 0.0156 t times the natural log of e. My answer is supposed to say t equals. So that means I need to get rid of everything that is not a t. I'm going to divide by 0.0156 times the natural log of e on both sides, so that those cancel out. So my answer will be whatever the natural log of 2 is divided by 0.0156, because the natural log of e is just 1. I'm getting 44.432, which we said our answer should be somewhere in between 44 and 45. 44.3, no, 44.4. All right. Okay. Are you guys okay with that? Okay. For time's sake, we're going to work one. I'm going to go to 3 is a little bit longer. Let's go to the very last problem. Let's do 6. So 6 says that there are currently 79 million cars in a certain country, and they are decreasing. So this time we're getting smaller, not bigger, decreasing by 7% annually. 79 million is what I started out with. How many years will it take for the country to only have 67 million cars? This is the same type of problem. So we're saying, when will the answer be 67 million when we have 79 million right now? We're still using e, but this time we're going to do 0.7 divided by 100, because you can't use the percent. So you're going to do 0.007, but it's going to be negative. Anybody know why it's going to be negative? Because it is decreasing. That's right. It says that we're going down, so we're decreasing. So we're making our exponent negative here. We're still talking about t. So we want to know how many years it's going to take for that to happen. The same type of problem. The only thing different with this is that we needed to know to make that exponent a negative. So we're going to divide by 79 on both sides, so that these cancel out and we get our e by itself. So 0.8481012, and it just keeps going. Okay, we need to take our natural log of both sides so that we can get our exponent down. That t can't be up there in the air and figure out what it is. So the natural log of 0.8481012 is equal to negative 0.007, because I can use that power property to move that down. We know we want the answer to be t. That's the only variable there is left. So we want to divide by everything else. We're going to divide by the negative 0.007. We're going to divide by the natural log of e. Which is just 1. So the natural log of all that 0.8481012 divided by negative 0.007 times 1, because that's what the natural log of e is 23.536, and it keeps going. So we would say 24 years. 23 years is not enough. Around into the nearest year, it's going to be 24 years. And so we will do part 2 of this on the next the next video.